Okay, thank you all for joining the first Wind Empowerment webinar of the 2015 series. Before we get started with the presentation today, I would like to say that if anyone is interested in becoming a presenter for one of our webinars, you can feel free to email me at jessica@winday.org, and that email address is on the chat bar on the side, so you can have that email address and email it to me. The aim of the webinars is pretty much to share any interesting projects that are going on or just to open up a dialogue between groups all around the world. They're very beneficial to all. We already have 4 uploaded on the website, and I'll be doing my best to upload the recording of each presentation after the presentation each time. And you can find that on the chat bar as well. I'll be putting a link there. So for today, our presenter is Nick.Smallman. He is currently a structural engineer at Ramboll in the Wind and Towers department. He came across the tower project that he's currently working on through his work, and he began working with a fellow co-worker along with the organization I Love Wind Power. He is excited to share with us the status of the project and is open to any ideas or support that we can provide. So without further ado, we will have Nick take it over.
Great. Thanks a lot, Jessica. Just to check, can you still hear me?
Yes, I can.
Awesome. Okay, I'll make a start then. And you can also see my screen still?
Yes.
Great. Okay. Good to go then. Well, yeah, thanks a lot for that. Yeah, as Jessica said, this is our tower project. We've been working on it for about a year or so, on and off, and it's now at quite a good stage that we can start to share what we're up to, what we're thinking, and hopefully get as much useful insight from you guys as possible, really. So without any further ado, I'm not sure if I can minimize this. Sorry. Okay, it's better. So a quick background of myself and Mark, not the project, just like our backgrounds, just so you get an understanding of where we're from. So we work for the offshore wind and towers team in Ramboll, based in London. Our day job is designing these structures that you see, so monopile, jacket, tripods, gravity-based foundations for offshore wind turbines. So it's a tenuous link really to wooden tower designs, but there is a slight link, I guess. I guess what I'm trying to say is that we're no experts at all in designing for wooden structures or wind turbine towers, say. But yeah, we've got a rough structural background, and there's lots of people from our department who do have more insight that we've managed to contact and can help out when possible, which has been great. Okay, so what we're going to talk about. I'll give you a quick overview of our project, so both the design aspect of it and the actual build aspect of it, and then how we've arrived at the design we've got, lots of different concepts we've looked at and developed, and what we've learned from other research and development projects that we've been aware of, and then how we arrived at our current design. There's little bits about it, so like the foundations that we're going to consider, how we're going to fix the turbine, how we plan on installing it, different types of connections, for example, and then what the next steps of the design on that we're working on at the moment, so the frequency analysis, and then what the next stages are, and then a brief section about the water pump, so the use of the final installed tower and turbine, and throughout, any input would be great. I realise you're all muted, so maybe if you just make a note of any useful tips or hints that we could take into our design and not make the same mistakes, then that would be great, and we'll go through it at the end. I'm sure we'll have a good discussion at the end, so I look forward to that. So a project overview. Firstly, why a wooden tower? I'm sure everyone has more experience in this than me, but the reason we've gone for a wooden tower is partly due to potential cost savings. So apparently in previous projects, the sourcing of the metal tubing, which makes up the vast majority of the tower, it's quite expensive, and you might not be able to actually source it in the location where you are. If there's only one supplier of such metal tubing, then it could be very, very expensive, and potentially could put pay to your project. If you had a turbine which is already made and all you wanted was a tower, then it avoids the need for welding kit, which could work out really well if you don't have any available at the time. And generally, it could work out to be quite a good backup. So you could go over with the intention of building a steel design, and then you'd have this in your back pocket in case it didn't work out for whatever reason, and you can still make your project happen. So yeah, there's a number of benefits to it really. Here are just some random pictures. So yeah, Central America, wood's been used in tower designs for many years, and I also found some fairly interesting pictures about a full-scale onshore turbine which is just been constructed out of wood, which would be pretty cool. So who's been involved in this project so far? Quite a few people. It's started with Pete, who's on the call. He set up the charity I Love Wind Power and has done been involved in several projects through them. He approached one of the guys from my company and put it to him, that asked whether he would want to be involved in this project. He then wasn't able to, unfortunately, so passed it on to me and Finn in the corner there. And then we worked on it for a bit. Finn left the company, other people have been involved. So Tom Kerr and Mark, also from Ramboll. Marco got involved. He has already completed the project in Brazil and has loads of useful insight into that, and is going to come out with us to eventually complete the project, which would be great. Tom from the University of Delft has been really helpful also, and obviously Pete and Jasper from Siemens have provided some really useful insight, and we've had regular meetings with them just to discuss the more technical aspects of our project and steer us in the right direction. So yeah, quite a few people have been involved so far. And the previous project that Marco conducted, it was in Montes Claros, which is just north of Rio. I say just north, it's quite far north of Rio, in Brazil. He ran a really successful project, and they are very interested in doing another workshop. Obviously, previously it was a steel tower that they used, which you can see here, but it's been highlighted as a really good place to trial a prototype for a woodland turbine, which is what we intend to do. We've been in contact with Luis Carlos, who's stood next to Marco here behind the turbine, and we're coordinating with him running a project, which I will come to. So it started off as a structural design project, and then when it became apparent that a project had been done in Brazil and there'd be a chance to go over and run a workshop, we contacted the Ramboll Foundation through our company Ramboll, and they very kindly offered to fund the project. So yeah, they provided money for materials, our time, flights, and expenses, and everything that would be required to conduct a 3-week workshop in Brazil, which is great. So then everything got moving fairly quickly after that. So it was split into 3 stages. Firstly, come up with a prototype for the tower, which we'll be doing in February, so next month. So this is partly the reason for the webinar now, to try and get as much input as possible before we try and build our prototype, to try and design in as much of that as possible. We then plan to do a workshop with V3 power. So neither myself or Mark Bridger actually know how to make these turbines, so we're going to do a workshop in that before flying out to Brazil in July to conduct the workshop for 3 weeks. So the design development, how we arrived with our current design, it's been quite a long process, and we've considered lots of different things. So we started off, we had a brainstorming session, or I think it was brain mapping, which is where so we did it at work, so with, we had a big group of people over lunchtime and split them all up into 4 different groups. And over a big A3 sheet of paper, we encouraged everyone to come up with a suggestion and then spend 10 minutes developing this design and then handing it around everyone in the group. So then you end up with sort of 4 variations of 4 themes. So this is the first theme. It's a sort of barrel concept, we called it, where you get your wood and arrange it in barrels, and then you can stack it up, which is fairly neat. We had loads of suggestions. So this was sort of a TP concept. which we developed into this, what you see on the left here. Its purpose was ease of installation, so you'd just be able to fold each one of the arms into each other, and with the turbine installed on one of them. Sort of based it on a bit of offshore foundations, so our background. We also looked at various other things, so this was another simple installation method. So the slats would fold up into separate rungs as you installed it, and it'd be very easy to take the turbine back down. The problem with these last two in particular is that it's quite tricky to scale this up to the sort of hub heights that we wanted. So unfortunately they got dimmed. And then we started developing the barrel concept. So we were quite keen at first to build the turbine out of a single piece of wood. So we looked into sort of furniture design and came up with this concept that you might be able to construct every single layer out of one section. So this would this circular section in the top left would be extrapolated up and pulled up, and that would form your tower. And we spent a bit of time going down that route, and spoke with Pete and Jasper as they produced their wooden tower concept also, which was installed over in Holland last year. I went over to see it. It's great. It's really, really impressive. We learned quite a lot from it. And yeah, the main points that we took away is the fact that it is possible. You can make a tower out of wood, and it does do a very, very, very good job. It's important to keep the connections as simple as possible. So these bolted connections considered in their design took an awful lot of time to fabricate. Lots of holes had to be drilled, and it took a long time to all of the bolts. So we tried to take that away and incorporate it into our design. And also the planning was also very important. So it's all well and good to come up with a great design on paper, but you need to make sure that it's buildable and you know the stages to do that. So we need to think about that. So we took that into our next design, and we were looking to come up with these slots, which are quite hard to explain really. But you basically take each one of these vertical slats, and it slots in like a jigsaw, and you can construct each one of your layers up from the base. So yeah, each of these horizontal sections have been cut out of the same bit of wood, so minimizing wastage. And then between each of the levels, you have these vertical slats which then slot into each other until you get up to your hub height. We thought it was a really neat solution, and liked it quite a lot, until we started putting it into ANSYS and looking at actually where the stress paths were and how the structure would behave, and realised actually it wasn't such a good idea for our hub height. We want the turbine to be between 12 and 15 metres above the ground. So it had to be constructed over many levels, and this guy in the bottom left-hand corner, which you can see, is to scale. So we're talking about a fairly substantial high tower, and to make that freestanding is very challenging, especially with this solution. So that was lots of the concepts that we explored, and eventually we came up with this solution. It's not that close to many of the other freestanding designs that we had thought about previously in the past. We basically realised that it didn't have to be freestanding necessarily. The guy wires aren't the item that's particularly hard to source. It was the metal poles. So actually, if we could just take the pole, put it to one side, and replace that with a wooden lattice, then that could do the same job and perform just as well. So we're looking for a 4-meter. A design that would work with a 4-meter rotor diameter and modular construction. With our design, we are going to construct the turbine and the tower in one location at a local school, and then we're going to transport it to site. So it's quite important that you be able to construct it in one place and then easily disassemble it, move it, and then install it at another location, which is, I'm sure, useful for most projects. Sorry, I should have mentioned that previous slide. Modularity was a big concern in this as well. We wanted a design that was very adaptable. So although we were looking for a 12-meter tower height, by considering this modular solution, actually you could have an 8-meter or a 12-meter or a 20-meter, or it's a very adaptable design, so you can change it for your site quite easily. But for now, source at the site and metre-and-a-half sections should be readily available. So a bit more on it. It's guided, as I said before. We've advised to keep the angle between the guy and the vertical of at least 50 degrees and no more than 70 degrees. So we've gone with 60. So the guys extend 7.2 meters out. Sorry, that's 60% of the hub height or the tower height of 12 meters. So yeah, it extends out 7.2 meters, which gives approximately a 10 by 10 area of land which you need. So it needs quite a lot of space, really. It can be located quite close to buildings, but yeah, it's much better if you can spread the legs out a bit more. And then we'll consider installation techniques similar to what have been conducted in the past. Actually, I think that's on the next slide. It's important to keep the wood raised off the ground to prevent water from ingressing through the timber. So that's why we'd consider a solution which would have metal angles essentially fixed into the ground, and then it would be bolted into the foot of the wooden tower, which we could then simply rotate and install. And then turbine fixation, we thought about this briefly. A number of suggestions, but yeah, we're not really sure which is the best to adopt with. At the moment, we're considering, on this image on the left-hand side, having a wooden slat through the centre of the top module, and having a metal pole extending down through this gap and down to the bottom of the first module, where there'll be another horizontal slat for it to attach to. And then the turbine would be able to sit on top of this. The benefits of this is that it limits the amount of clamping that would be required, which could be quite complicated or fairly expensive, depending on if you can get the equipment that you need. The other option, obviously, is just to attach it to one of the 4 sides. We went for 4 sides, by the way, just because it would be much easier to construct than 3. So these angles, I wonder if I can show a better picture. So these slats could simply be nailed or screwed into the vertical members due to the 90-degree angle between each of the spaces. If you wanted only 3 faces, then suddenly this joint becomes much more complicated, and you couldn't just simply connect the 2. The other beauty of this design is that hopefully you would be able to only use 1 or potentially 2 pieces of timber, and that would do you for the whole design. All of these sections, so the horizontals and the diagonals, would all be made out of the same section, just cut into obviously different shapes and sizes, and potentially and then a square section for each of the legs. You could also come up with I can't think what the word is. Like a sort of template to make the cutting of these angles easier, and then you could just keep reproducing lots and lots and lots, and then install it later. So in terms of actually manufacturing each of the members that you would need, that should be fairly simple as well. So in terms of buildability, this is we think this design is quite good. And then installation, similar to the previous steel towers we were thinking. So we want to try and keep the weight down as much as possible, and then install either through manpower or other through the use of a boom, and like you can see on the right hand side there. And we're also looking into alternatives for the guys through Wind Empowerment. I can't remember where Pete got the link from, but there was a very interesting manual on using normal guy wires, which avoided using cable clamps. So you'd use, I think it's similar to chicken wire, I think, but I'll have to double check. And you can basically fabricate your guys out of this material, and that would help to keep the cost down also. So yeah, we need to check that would work in terms of loading for our design. And then connections, as I said before, we see as being a really important point. A colleague from Ramboll has worked on wooden products before, and unless you're careful with the connections that you're specifying, they will easily end up being more expensive than the wooden parts themselves. So it's an area that we need to make sure we get right. Also, if our tower doesn't actually behave like a lattice, then it won't work like a lattice. If if the joints don't work like a lattice, then our structure won't really work at all. So it's very important that as well as each of the connections between the different modules, that these diagonals are also connected to the legs in a suitable manner, that the structure behaves how we'd want it to. So option one is the metal angles. So we just find out what we can get over there and use those to make our connections. Option two is making the connections through a section that we'd make ourselves. So we'd add a separate bit of wood and nail, or probably screw or bolt into the parent leg, and yeah, the connection would be made like that. We're also looking into if you could only get the one single bit of wood. So if these legs were a rectangular shape rather than square, as this diagram suggests, how you could connect the horizontals and diagonals to that. If they weren't square and if they were rectangular, which is what this bottom plot's showing, so you could potentially have some sort of angle connecting two sections together, and then each of the horizontals and diagonals would be connected into these legs, as this diagram shows. Sorry, it's not. Yeah, it's not particularly clear, that one, but yeah, that's what we're trying to show. So yeah, connection design we see as being quite important. And then the next steps. So at the moment, I'm conducting calcs to work out if the extreme event, so the biggest wind that we could expect, if it's going to be strong enough and robust enough, and what section sizes we would require. Also of concern is the frequency of the structure. We talked about this a couple of weeks ago with Pete. He brought it up. Is that actually the dynamic loading on the structure from the turbine is also very important. We have no idea how stiff our structure is. We think it's very stiff, but as for determining how many levels we need or how many diagonals we need or how big the section sizes are, this is much more likely to be driven through the frequency requirements of the structure rather than actually the ultimate limit state and being able to stand up to an extreme gust or an extreme wind speed or something like that. So we anticipate we're probably going to be somewhere in this stiff region. So as I'm sure many of you know, the two of the larger excitation modes are the 1P and the 3P frequency, i.e. a one mode for every single rotation of the blades, so all the way around, or 3P, so every single time that a blade passes the tower, you get a mode shape. There's a rough example. Oh, sorry, check the bottom again. There's a rough example in the bottom corner of the frequencies that we probably have to avoid. Obviously, this isn't. Yeah, this is just an example. We'd have to check with the turbine that we're producing what the tip-to-speed ratios are and what the rated wind speeds are likely to be. But in this example, the 1P would be about 5.5 hertz, and the 3P would be about 16.8 hertz, which would come across to this plot. And then it's very important that you stay away from these bands. So we were looking to conduct a sensitivity analysis in ANSYS, and we were using SolidWorks to create the models, and then using ANSYS to run a frequency analysis to determine where we lie. So we started off with, we will start off with our current design, which you can see here, which has got one diagonal per module. So that's a rough module shown on the right-hand side. So one module for the first one, and then another one, and so on. And the larger section sizes, which we're currently considering. So those are rectangular sections of 200 millimeters in diameter and 40 millimeters thick, which you can see on the right-hand side, and one diagonal. So we want to see what the frequency response is of that structure, and then we would change it to slimmer section sizes. So still with one diagonal, and then halving each of the section sizes. So we'd now be considering 100 mil and 20 mil, and so a far slender tower, and see what the response would be. And then revert back to our larger member sizes and see what the impact of having additional diagonal bracings would be. As you can see on the right quite clearly. It will obviously make it a lot stiffer, but we want to see if we're closer or further away to these bands, or if they're necessary. obviously the smaller sections and the minimizing the number of diagonals is beneficial to weight and build time, so we'd be looking to reduce those as much as possible. But yeah, we don't know how important it would be. And then the final iteration would be this reverting back to the smaller beam sizes, but also with the 3 vertical braces or horizontal braces. Okay, and then a brief section on the water pumps from Brazil. This is one area that I know very, very little about. So colleagues just put a slide together. This is more just to get your responses on, I'm afraid. So we're going for a DC pump. So after the workshop is actually completed, we're going to be disassembling the tower and moving the turbine to a local farm. It's then going to be used to power a water pump for a local irrigation system, and yeah, we'll be using a direct current pump. So yeah, without using the need for batteries and other expensive electricals. So apparently it can be driven directly from the rectifier output, and it's possible to run with a duty cycle, so wind power. And yeah, this was roughly what we were considering. Trying to get up 20 meters in 44 meters, a 5mm diameter pipe. We think that would require a 24-volt DC pump. Wouldn't be massively expensive. The tank would fill up in about 9 hours of operation. And yeah, the tank. Currently the tank fills up in about an hour. But I mean, 9 hours is still feasible. The conclusion is that it's possible, but the flow rate would need to be greatly reduced compared to today. We'll have to check if that's a problem, but I don't think it would be. And we could also always use 2 pumps if the flow rate wasn't sufficient. Okay, that's pretty much my presentation. Now, so yeah, thanks for listening. I hope there's still people on the line. It would now be great if we could just, if there are any questions at all, or any points that you'd like to make out, or anything that you think would be able to help us develop our design further, or that we need to think about, if we could just have a discussion about that now, that'd be great. If you're watching this later as a video, then mine and Mark's email addresses are at the bottom of the screen, so please get in contact if you want to know anything else about the project, or if you've got any suggestions, then yeah, we look forward to hearing from you. Cool, thanks for listening. I don't know how to unmute everyone. Anyone still there?
I'm here, can you hear me? Hello?
I hear you.
Hi, I'm still.
I can hear you.
Right. Thank you so much for that, Nick. And I think there's still people around. I unmuted everyone. So let's see if anyone has any questions for you.
Well, I like the way that you fixed the head of the machine onto I guess the last part of the tower. But it's something that I'd be kind of worried about, because that's where the most amount of effort is. And just seeing how better to enforce or reinforce that tube fixture, especially with a 4-meter diameter machine. I'd be really worried about that wobbling around a bit, or even having the tube bending. A lot of times what we would have to do is use a much larger tube, and then just have the last bit of the tube be the smaller one enter into the turbine nacelle.
Yeah, I think Pete mentioned that. So in this diagram on the left you're talking about, I guess. So you'll have a larger diameter into quite a lot higher up. I think that's a good point. I think we would have to consider that. And another thing we were wondering is whether we actually would have to have this pole extending all the way up, or whether the blades would be able to pass the tower itself. I'm not sure if that's an option, but
yeah, I think because what we're talking about 1 meter by 1 meter, it's kind of big. So yeah, the tube up near the top.
Yeah, sorry,
would need to do some welding.
Yeah, the towers, it would be probably less than half a meter, so either 300 mil or 500 mil wide. But 500 mil, yeah, half a meter or 200 centimeters.
And for the tower design, I was wondering if those I guess the larger 4x4, I guess equivalent of 4x4, that's something probably would have to buy. But whether if the spars, if you could just use shipping pallets. Like,
sorry, what do you mean by what are the spires?
The spar, so you have the larger ones, and then you have the very thin or thinner supports, the lateral supports, the ones that go diagonally. If that, you probably could be able to use shipping, like some shipping pallets. Yeah, exactly.
Yeah. That
would.
Especially if you needed, if you used more. That might be slightly too long, but that's quite a good suggestion for this. Yeah, you'd just be able to, essentially just rip it up and fasten them diagonally.
Yeah, it's a big
nice.
perhaps a lot of people build furniture out of shipping containers, chairs, bureaus, workshops, whatever. And the advantage is it's all free or.
Yeah, definitely. And I guess you could always use it. Yeah, you could try and use the I don't know, the sections in between the shipping pallets, so the square sections, as the legs also. I don't know how long they would be, but yeah, I'm sure you'd be able to.
A lot of times there aren't any larger sections. You just have a short. You have the short pieces, and then you use a lot of times just blocks now. So you're. A lot of times you don't have a decent piece of wood there because they try to cut down on the cost as well. And how are the guy wires fixed to the wooden tower? I don't know if I missed that or.
Oh no, I didn't say. We're not entirely sure. I think there'll probably be a small sort of eye section screwed onto them. So there'll be you'd have to buy a separate fastener and then just attach those to probably the top or the bottom of each of the modules.
Okay.
But yeah, that's one area that we haven't really looked into too much yet.
I've got a question.
Yeah, and also
about connecting the sections together. Go ahead.
Sorry?
I was wondering about connecting your 1.5 meter sections together. If you'd consider just pinning them, it would be a lot easier to put them together, ship them. It'd be a lot quicker to do. I don't know how it would play out on price, but if you drill the hole in each square section up and down and just use 20 centimeter pin to put them together.
Okay, so we're going back to sort of this sort of thing.
Yeah.
And then, sorry, where would the pin go?
You can't really see it, but the square section, where each square section lines up, if you were to drill a hole up and down and just put a pin in between the two of them, that way you have 2 holes to drill, and all you have to do is slide all the pieces together when you get there, rather than having to bolt or screw or nail.
I think that makes sense. I'm trying to envisage it. So you'd have this square section on the top and the bottom, and then you would. Right. So then there'd be a pin coming up and a hole in the top one, and then they would just slot together.
Yeah, exactly.
Yeah, I can see that working. Yeah, I can see that working. Yeah, I could do it. Can you possibly send a sketch of how you do that? I'm not
sure.
Quite.
Yeah. The easiest way to describe it, and probably not the best way to describe it, would be think IKEA furniture.
Yeah. Okay.
Yeah, I'd probably sketch.
Yeah, what I'd probably just do.
Okay.
I like the picture that's there. I think that's a pretty good idea. And what you just do is use big wood screws, and so you put a hole in the outer brace, and then you drill right into the wood 4x4 that's behind it.
Yeah.
So that way you don't need bolts. You just screw it right in.
So, yeah, I'm trying to think if it. Yeah. We saw that as being fairly simple, and then you'd be able to take it apart again and move it if necessary. I'm trying to think if it was pinned, if that would, would that survive if in like sort of axle loading, or I can't really think how that would work.
Yeah, you'd have to have a fatter piece of wood. I don't think it would work in your skinnier model.
Yeah. Okay. Yeah. Yeah, if you could if you could possibly send just a very simple sketch over, that would be great. And yeah, we'll take a look at it. I can't quite work out what.
I think, Nick, I think the idea that's just being proposed is a really good idea. I just wonder whether it might be a problem like feasibility problem when we drill holes. We need to be really careful and drill it really straight and vertical, because then obviously if you don't have it perfectly done, then when you assemble it as an IKEA kind of thing, and you will have your tower not be a lattice tower anymore. So I think it's a really good idea. Will be saving us a lot of time, but we need to be sure that whether we use pins, we do it such that we can drill holes really straight and in the same way in both parts, top and down parts, and the connection. Another thing I see, I don't know if you were thinking about doing with the wood, pin wood, like real. I don't think it will work out with the kind of real IKEA pin boots, but if you do it with metal, I don't know whether it will kind of get rust inside and make the wood rotten quicker. I really don't know, but it's something that we need to check out. But it looks a really great idea.
It's something we'll be able to test out fairly easily as well. So we were intending on making one of the modules or two of the modules and then connecting them together and testing it. So yeah, we could always, I don't know, make one connection on two of the legs and a different connection on the other two legs, and yeah, see which works out best. So yeah, we can definitely try a pin connection.
Yeah, it sounds really good. And also we can, we can try both on the same modules. We don't need to build any other more, because the junction that you just showed in the presentation are a kind of external junction, and the one that Jay just suggested are internal, so that would be perfect.
Yeah. Cool. Yeah, thanks for that. That's a really good idea.
Could I ask a question?
Sure.
Okay, so Nick, thank you very much for presenting and sharing your work with us today. I very much enjoyed what you've been talking about. I really liked the fact that you're going on a V2 Power workshop. They're great guys, and I'm sure you'll learn a lot from the experience as well as having a good time. I really like the modular aspect of the design and the fact that you're using stock sizes of wood, so just a couple of different types of wood to build that entire structure. I like the fact that it was it's a good option as a backup if steel is not available. I was wondering about if you need a welder to build the turbine itself, as in the generator and the tail and everything, is it such an advantage not to be using a welder for the tower as well?
No, yeah, I mean, if you've got a welder, then yeah, that's not a benefit of our suggestion. I guess it was more if you had a turbine already installed and you needed a tower, or if your tower broke and you didn't have a welder on site, or it's just one potential benefit really. But yeah, I don't think you'd need a welder for any part of this design. So.
Well, not just that, but
okay, I did have a couple more questions.
Part of the top that could be built before in the shop, and since it's the same size as the blades anyway, or just a little bit longer than the blades, it's easy enough to transport.
Yeah.
True, I think that's quite a big thing actually, isn't it? In that carrying sections of a tower is quite a constraint on what kind of transport you can use getting to site.
Yeah, so yeah, well, I'm not sure exactly how heavy each of the modules are, but I anticipate that you'll be able to, one or two people will be able to carry one fairly easily, and then load it into the back of the truck and off you go, and then you wouldn't need any welding kit on site. So yeah, I guess it'll have that benefit also.
Yeah, and you wouldn't need a vehicle that has a certain length to it as well, and you wouldn't end up. I was wondering about what impact is the wooden tower likely to have on the the effect of a lightning strike, because if you've got a steel tower, then you can ground the tower, and if there's a lightning strike, then the lightning is likely to go down the tower as well as down the copper power cable as well. But if you've got a wooden tower, there's only one route for it to go to get to ground, and that's through your electrical system. So are you increasing the risk of damage from a lightning strike by reducing the pathways for lightning?
That's an interesting topic. Something we haven't actually considered yet at all. I guess if you somehow connected a pathway between the turbine or the turbine itself and the guy wires, I suppose they would maybe form a pathway for the for an electrical bolt to go through rather than your electrical systems. I'm not sure. Maybe someone else would be able to suggest something.
Well, I think the risk of having your wind turbine being actually hit by lightning is very minimum compared to the risk of having the lightning hitting next to it and following the wire to the electronics anyway. Afterwards, you could always just run a copper wire up the wooden tower and fix that onto the tower stub at the top of the tower.
Okay, so yeah,
true. That is adding an extra cost there.
Yep. But
Do you know what
otherwise,
the costs? Have you done any kind of preliminary costing so far of the wooden versus steel tower?
We have, in this. I'm not sure I'll be able to dig up the.
Just as a rough indication, like, are they kind of comparable? Is one double the other, or how are they?
I'm not sure. We haven't costed up this design. I'm not sure. I guess it depends. How much the metal one cost really, and how much the materials are. It was. I remember it was looking good, but we haven't costed up this exact design, so I'm not sure. I'm afraid.
I think it probably depends on a lot about where you live. If you live somewhere back in the middle of nowhere with a lot of trees around, or if you live near a port with a lot of steel being shipped in.
Yeah, and it would just be nice if you go somewhere you're not tied into absolutely having to source steel, so you haven't got that risk to your project of not being able to source it, or just being stuck to one supplier, or not being able to get exactly what you want or the right height or whatever. So I guess it just gives you a bit more flexibility also.
Yeah, completely. I think each local context is different. This is what we've seen from having this huge collection of people who are building very similar turbines in different parts of the world, in that the context in which they're working are very different. The amount of lightning strikes, the materials and skills that are available in each place, the level of corrosion present in the environment are all different. So having an array of different options to draw upon is really important if the design is going to spread to new places and be more effective in the places where it currently is.
Yeah, I agree.
Have you looked into what the maximum wind loadings would be in the region of Brazil where you're proposing to install a prototype? As in, is that region frequently hit by hurricanes? And if so, would this tower stay up?
Hurricane loading, I'm not sure about. I don't think so. We did. I can't remember what wind speeds we were considering for an extreme, but I think it was of the order of 20 meters per second. So quite severe. But yeah, I'm not sure exactly how strong the winds are on the side. I don't think it's particularly windy. I remember looking at the wind map and realising that actually maybe it wouldn't be the best place for really for a turbine. But I don't think the extreme loads are excessive in Brazil. But yeah, I haven't looked into what the exact extremes would be.
20 meters per second seems pretty low. I mean, if you say it's installed in a low wind area, then maybe that's realistic. But for most good wind sites, I'd imagine you would see probably at least 40 meters per second every now and then. In terms of gusts, maybe up to 50 or 60.
Okay. So I'm just making a note. Okay. Yeah, we'll have to.
I think on the British.
Sorry, Mark, go on.
I was just going to say, I think on the British standards they say designed for 50 meters per second, although it's been a little while since I looked at them. Have you looked at the British standards for small wind turbine design? 65, is it?
Yeah.
Yeah, I have had a look. I'm not really sure in my calcs. Yeah, I'd have to look back into it. Oh yeah, I can't remember what wind speed we considered exactly. But yeah, I don't think. Yeah, looking at the wind map of the the area of Brazil we're considering, I don't think it was as windy as the UK. But yeah, we have been looking at British standards in our design. But we need to look into exactly what wind speed to consider.
So from what I remember from the standards, it is what we're looking at is 65 meters a second, and we're looking at the machine stopped. You don't have to look at the machine turning because you can consider the machine's completely furled or it's short-circuited. And so you're looking at the surface of the blades, the actual surface of the blades, not of the whole turbine, and at 65 meters a second.
Okay, and then wind loading, based on the shear effects on the tower itself.
As well, yeah, because that tower is going to have much more resistance than a metal tubular tower.
Yeah.
I think looking at the size of the amount of the wood that's there.
Yeah. Yeah, we're also going to consider that.
Okay, and how far have you guys gotten on the pumping system?
Not very. I know very little about it.
Yeah, I think taking over from this side, there is another team member who is looking at the pumping system. In the presentation, you have seen basically the system we are trying to power. It actually wasn't, from my side, wasn't the clearest possible. But basically, what you're trying to achieve is pumping water downhill for 20 meters high drop, and for the length of 45 meters. So in general, we will not use a lot of power to do that. We looked into the DC systems, if it was possible, and apparently it is. And these are basically, at the moment we are investigating two different DC pumps. And we actually put these slides together just to get maybe some feedback from the broader community, because we don't have any experience on these kind of systems. So far that's what we got. We were hoping for any input and feedback, but otherwise we're gonna proceed on this way and probably looking at these kind of pumps, DC or 24 volts systems.
Okay, yeah, what I would wonder is if you have your pump, like if you have a 500 watt pump, well, what happens when you have less than the 500 watts, and what happens when you have more than 500 watts?
Yeah, that's a really...
Sorry, go on.
Sorry? I think in the pump specification is written that basically if it doesn't achieve the kind of threshold energy, doesn't activate the pump, and automatically dissipates the extra energy that it gets to work out. So it should be able to work in a specific range of power that should be enough to cover our turbine output. Considering that even in the best case scenario, I think here we put 500 watts. I think it's actually best case scenario is a little bit higher, around 800 watts. But I think in the requirements of the pump is the range is covered.
You might need to add a system with some sort of regulator onto it to keep the pump from burning out once the wind turbine is making too much energy. So dissipating a little bit of energy with a resistance or something like that.
Yeah, exactly. I think in the pump itself there is a system like that, but obviously it's a good point. We will need to double check that and not too much power comes in and burns out the whole system.
Yeah.
Is there any way you could connect the pump before the rectifier and just take out one more step between the system? I have no idea.
Well, Grundfos had done a lot of work with the system. Well, a very expensive pump, but with you could use it in DC, AC, different voltages, different tensions, the SQ Flex, and they were installing that with some of the Southwest machines, the Whispers, back about 10 years ago.
Who was that?
That's Grundfos, SQ Flex.
Yeah, it's a good thing to investigate. I think we need to do much more work on pumps because, to be honest, also the data we got from Brazil, from the Brazilians, local Brazilians living there, are for me as kind of a little bit unrealistic. I want to double check because, to be honest, yeah, a flow rate of 167 liters per minute. I don't think even the fireman can play that kind of water flow. So I don't really believe that they can fill a 10,000 liters tank in 1 hour. I really want to check that because especially with a 5 mm diameter, yeah, I don't even know if it's possible actually.
So, sorry, does anyone have any experience in actually installing a DC pump with a small wind turbine or a small turbine?
Yeah, well, we did. We installed a pumping system quite a few years ago using a African wind power machine, and we had a lot of problems getting it, being able to handle the extra energy, and how to handle the extra energy when you go over the level of the pump. So when you overpower the pump's motor, and we had a regulator system before without batteries, and finally we ended up throwing a couple of batteries in to try to slow down the peaks in energy. And I don't know, I haven't found a good system yet for pumping with pumping in direct from a wind turbine.
Okay, so were the batteries used as overspill, or did the batteries directly power the pump?
Yeah, well, what we eventually put in was putting in where the batteries were powering the pump. Well, it was being powered by the wind turbine, but when the wind turbine wasn't supplying enough energy to start up the pump, that energy was going into batteries. And when the wind turbine was going, so the pump would just work between its range of voltage. The problem is if you turn the pump too slowly, you risk to destroy the pump, and if you turn it too fast, you risk to destroy the pump. So
it is better to actually go through a battery.
yeah, well, a battery, or just figure out a smarter electronic. I mean, we didn't have something that was very complicated, I think, and so, well, maybe it was too complicated, and that's why it didn't work. But a lot of the pumping they're doing in Senegal, they're using on battery systems.
Okay, and then sorry,
Sorry?
I know, yeah, so I know little about electronics. So then, if it's through batteries, then you could use an AC pump.
Oh, no, you'd use usually a DC pump with 2 batteries, and so you have the wind turbine or rectifier. You'd probably want to have some sort of over voltage protection, and then you'd have you just have to have a controller between the pump, and I think some of the pumps now come with that. If you don't have a high enough voltage, the pump doesn't start working. So if your frequency isn't high, if your not frequency, if your voltage isn't high enough, the pump won't start up. And if it goes too high, it'll stop. So.
Yeah, this is exactly the system we're looking for because obviously we don't want to pay extra money for voltage regulators, and the idea was really to try to avoid batteries as well, to try to reduce cost. So I think it's a really good good input that you gave us, and we might need consider to spend a little bit more money on a reliable pump that actually cut off peaks and let's say valleys of current,
voltage,
such that we can just use it. Yeah, voltage, such that we can just use it at the right in the right way.
it sounds, Marco, that we might still have some problems, even even if we get the right pump, that due to just the intermittent nature of it, that it's still not going to. We might have to come up with another solution.
Well, that's really the advantage of a battery-based system, is that the battery-based system you don't need to worry about. The pump, you can use whatever pump you want. But the problem is afterwards you've got to have batteries, and the batteries die, or even if the batteries are dead, it still works a little bit. But well, especially in places where the weather is very warm and the batteries don't last very long.
Okay. And
that's what I wanted to try.
Sorry, from your experience today, the batteries, are they much more expensive than the pumps themselves, or I mean, is it a big complexity issue or expense issue actually using batteries, or it's just the fact that they die themselves also? So.
Well, yeah, I'd say it just depends on the size of your system. You have to have the batteries that are big enough to keep the wind turbine under control. If the batteries are too small, it just goes up and down too quickly. But still, the idea would be having a decent size. You'd still have to have a decent size regulator. So the regulator, the idea would be that it would take away a little bit of the energy, so the batteries don't get overcharged, and also to keep the wind turbine from overspeeding. So I don't know, the pumping, I know there's some people in the wind empowerment that are working on pumping systems. I haven't done too much in it, so.
Okay. Great. Well, yeah, thanks for that.
I think
that's all you need to me.
we're talking to these experts.
Yeah, I think
thank you
that
very much, guys, for
the organization that does a lot with water pumps is Comet. So I can get you some information from them, Nick, and send it over your way.
That would be great, Jessica. Thanks a lot.
Mm-hmm. Well, are there any other questions?
No, but it was really an interesting presentation. It was nice to see what people are doing at some wood towers and see some new ideas.
Yeah, it has been a wonderful webinar. It was a nice presentation to get to see what the new projects are being, brought upon. So it's going to be neat. I really enjoyed it.
Yeah,
I have one quick question for you, Jessica.
Go ahead, John.
Jessica, what is next on this webinar series for 2015?
The next one, we're still in the works, but I'm hoping to get Luis to talk about the controller that he's trying to build. So maybe he can give us a status on that project. So that'd be interesting as well.
Great. Well, looking forward to it. We hopefully will have one on the website soon as we finalize the layout of it for everyone. So that will kind of follow on to the session that we had at the conference in Athens.
Yeah, exactly.
So yeah, thanks a lot to Jessica, and thank you to Nick as well. Really appreciate you giving up your time to share your work with us.
Not at all. Thanks. Yeah, thanks for all your input. It was all very helpful. And we'll take as much on board as we can. We might be asking more questions soon. We'll try and keep everyone up to date. So like I don't know if it's possible to post a blog or something on the Wind Empowerment site after we actually complete the project, and we feedback any information that we find which might be useful.
A blog would be fantastic. We're absolutely positively trying to encourage knowledge sharing in any form, and we do have a news section on there, so something around 500 words or so with some nice pictures and even some videos would be a fantastic way of sharing what you're doing, in addition to the webinar, of course, and an update on where you've got to in a few months' time.
Sure. Yeah, we'll definitely do that.
Alrighty then. Thank you to everyone who participated and joined on the webinar. You all have a great
Thanks, guys. Cheers. Nice speaking to you all.